Many of you know that, at least if you've been watching this channel for any length of time, probably the last, oh gosh, almost 4 years, I've been looking for a desktop replacement based on ARM. ARM is one of my favorite pursuits. This journey has been long and arduous, going through many different manufacturers of ARM boards. Now, I'm not talking about system server type boards. I'm talking about very small computers, like the ones you see. Well, if I move my microphone, you can see it. It's right back there on the shelf with the robot. Those are all the ones that I have been placing into my shop here, my lab, and using them on a daily basis. So I had an email from a company called Mixtile, and they offered to send me a computer module that they have developed, and they wanted me to do a look at it and maybe create a video about it. But I don't want to spend a lot of time talking about speeds and feeds. I'll cover that. But this is what they sent, and this includes a lot of stuff. So the carrier board is the larger board here. This is provided by LeeTop. This is not Mixtile, as part of the Mixtile company, as far as I can tell. And it is the way that you bring the interfaces out from the actual computer module. So the computer modules, just like Raspberry Pi has a Raspberry Pi 4 that is a CM module, just like that, they go into basically a RAM slot called a SODIMM, and then you can use the carrier board as your basis for interfaces to the compute module. That allows you to move this around to different carrier boards to be able to provide different functions that you might need. And in this case, this is kind of unique. The computer module that comes from Mixtile actually can plug in to a Nvidia Jetson carrier board. So that gives you a pretty wide range of things to use. It also has a cooler here that they shipped with this. And so, yeah, we're going to go take a look at this a little bit in depth. Like I said, we'll cover some of it, but you might also hear this part right here called that's the cooler, but the board under it, you may also hear it called a SOM, system on a module. Both of them are correct. I've heard interchangeably, I've heard them called that. This one is kind of unique. It's based on a Rockchip 3588, and that particular processor has a number of features that we should talk about. First, it has 8 cores total, 4 of which are performance cores, and those run at 2.4 gigahertz. The other 4 are efficiency cores, which run at 1.8 gigahertz. There's a GPU, and that's a Mali G610. But this is the unique part. Not all ARM chips come with an NPU. What's an NPU? That's a neural processing unit. And this one offers up to 6 TOPS of performance. NPUs can be used to accelerate AI workloads. And they are much better at it than a GPU. And it is more adept at handling those workloads than a GPU. You can get this in either 4 gig, 16, or 32 gig. It uses LPDDR4 memory. And then on board, there is a storage device called an eMMC. You can purchase the CM with either 32 gig, 128, or 256 gig. Now, on ARM chips, you can't upgrade them other than swap out the CM module. What about the carrier board? So we should talk about that. The obvious place to start would be on the back here. So there is, coming from this side, there's a USB, a mini USB here that's used to bring in power. It does function as a normal USB. And then you have a 1 gigabit Ethernet port. You have 4 USB ports. Then you have something that I have not seen on a ARM board. You have a display adapter here, and then an HDMI adapter down here. This particular CM supports 8K, up to 8K video, which is interesting. And then you have a standard connector for power here, which is providing from 9 to 19 volts. I'm powering mine with, it's one out of an old Nvidia Jetson AGX board that uses, I think it's 19 volts and 3.4 amps, which is more than enough for this board. It seems to work just fine. And then on the side here, there are two CSI connectors, which are used for cameras. On the back, there is a bunch of plugs. One of them is one series is to allow you to set particular types of switches in order to bring different functionality out on this board. And then there's a CAN header. There's a fan header, which allows you to connect a PWM fan, so it will change speed as the processor or any of the other core functions heat up on the CM. There's a 40-pin header here that's similar to the Raspberry Pi, and then there's a 260-pin SODIMM connector, which is used to plug in the compute module. And an LED up here that is a status LED that indicates health. So it's blue if it's flashing. It's telling if it's flashing in kind of a rhythmic pattern, that means all is good. You're good to go. On the bottom of the carrier board, there are two NVMe slots. The first one is the longer one here, which is used to attach an M.2 NVMe. And the shorter one is for Wi-Fi. So or I should say it's right here. And then there's an SD connector. One thing I will tell you that this particular LeeTop has some problems with performance on the SD card. So I wouldn't suggest using that for anything until maybe they get it fixed. This is the real-time clock for a battery here. And that's basically it. So I tell you what, let's talk a little bit about the software that comes with it, because that's kind of unique as well. So in the past, most of the ARM vendors have gone through a whole bunch of different ways of getting Linux or any other Android or whatever onto their boards. And those have been all the way from the gamut of, oh my God, what were you thinking, to, well, that's better. Yeah, but this one is very unique. When all you have to do with this is plug the CM module into a carrier board, plug in your display, your keyboard, your mouse, and your Ethernet jack, and then plug power in. And when it comes up for the first time on your monitor will be the installer for Ubuntu 22.04 LTS. It's already waiting for you to get started. It comes with a kernel that is customized specifically for the feature set that's on the Mixtile SOM as well as the Lee carrier board. Now, I have not tried it with plugging it into a Nvidia carrier board simply because it's in use. So, yeah, I don't want to just tear it apart and put a new one in. It's doing stuff back there. So that's all you have to do is you plug it in and it comes up and it acts like you're installing it off of an SD card or off of a USB stick. Mixtile supplied me with this particular compute module. Comes with 16 gig of RAM, 128 gig of eMMC, and they also supplied the LeeTop A505 and this excellent cooler here. It is very quiet until you get up to 100% on the CPUs. And then, yeah, you can hear the fan at that point. But it's not objectionable. So I want to compare this today with 4 different boards. I want to compare it with a Jetson or a Nano, which is one of the latest Jetson Nanos from Nvidia. That's an 8 gig board with 500, and I have a 512 gigabyte NVMe that I've attached to it that it's running on. Then I'm going to compare it with a Kadas Edge 2. Why the Edge 2? It has a similar chipset to the one on the Mixtile. They're not exactly the same. The Kadas has a 3588 This is a Rockchip 3588E that's on the Mixtile. The Kadas, I better tell you how much memory it is 16 gig, just like this one. And it's 64 gigabyte eMMC, so it has about half the storage of the Mixtile. I'm also going to compare it to a Kadas Vim 4 just because it's the older generation, but I'm curious to see how much of a change there was from the Vim 4 to the Edge, and then from the Edge to the Mixtile, if there is any. And then we'll look at a Raspberry Pi 5 because that's where everybody focuses their attention today when they're talking about small form factor desktops. So that one has 8 gig of RAM, and it has a 512 gigabyte storage device that is provided through the USB ports using Samsung T5. So yeah, that's what I'm going to be doing today. As far as the price is concerned about this board, I'm going to put a link below. You can check out the website. Those fluctuate. If I say, oh, it's this, and then you're watching this a year from now and the prices are up or down, you're going to go, wow, he didn't know what he was talking about. That isn't anywhere near what he said it was. So go check out the prices on their website. And also check out not only the CM here, but also check out some of their other products as well. They have some pretty amazing things like the Blade 3, which is an interesting piece of technology as well. So with that, let's go dig in a little bit, kick the tires, see how things work, and then we'll come back and I'll give you my final thoughts. So yeah, as you can see that it comes with GNOME, has a number of applications that come with it. I, of course, have added a number on my own with it. So as you can see, I've got I've installed quite a few packages because one, I'm benchmarking, and two, I'm also doing some other things with the board to see how well it works with AI, as you'll see today. But yeah, just as I said, now some of these don't. Well, I guess it does. It's 16 gig. There's some memory that's taken away from the main memory because that's shared with the GPU, the Mali processor. So yeah, and of course that is being used here to be able to do the display right here. There's the GPU, there's the NPU. Now NPUs require work in order to program those in order to be used, just like a graphics card does. They don't automatically come in and start working on workloads. They have to be told what to run, and then they will process. They're really meant for the interpretive side of AI. So anyway, let's look at the stuff that we normally would. So let's take a look at how much disk it's taking. Just remember, this is not out of the box. So I have a number of language models installed on this. So I'm using about 59 gig, and some of those language models are, in one case, one of them is 26 gig. So yeah, they're quite large. Of course, the available space is 51 gig. That leaves me about 54% available on this. And I have added another drive so that I can expand beyond that and get some additional storage. So I've got another 463 gig that I can tap into for my models if I want to. If I start needing to dive into that. Now I have hardened this somewhat, not completely, but somewhat. I think the score was 66%. So yeah, a failing grade, but then Ubuntu is always is. Yeah, 85 is where it's sitting right now. There's some. Yeah, this is as a result of my work in trying to get some of the things to work with AI. The rest of it is fairly standard. These are always things that I run into needing to harden. So over time, I will harden this down further. We will clip that. Let's put this up and just see how well it works in transfer. And we'll also go full screen on it. Eek, there's two of me. So as you can see, it is dropping some frames. However, that looks like it's dropping them as I go through the transitions. Yeah, it's dropping them as it goes through the transitions. Okay, so I have the benchmarks up, and I decided to just do the Edge 2, which is from Kadas. This would be the Nvidia Jetson Orin Nano, which is the newer board, and the Mixtile, and then the Pi 5. So let's look at the overall scores. So the first one is in MB the test results. So this would be I/O. Yes, it's not going to be as fast as these two because they're both using NVMe's. So yeah, but that's respectable. And of course, this is a USB drive, so it's not going to be real great. The MB, yeah, it's similar in the way it worked. The BOGO ops, the Edge 2, what did better here in this particular test and the ops per second. But overall, look at this. I mean, it is very close to the Edge. Funny. Sorry, I didn't mean the pun. But yeah, it's doing very well up against that one. And in the geometric mean of the C compiler test, it kind of squeaks out a lead and drops back a little bit on the CPU massive tests. Geometric mean for creative loads, Mixtile was first in this test, although it's pretty close. And the same here with the geometric mean of encoding tests. Also, the high performance computing tests, the Jetson did better here because it has a higher performing GPU, which favors this kind of a workload. So the problem is that for these two boards, they're both relying on Mali, which doesn't have full support. Now, I did notice that there is still a lot of work being done by the kernel team to bring the Mali into the spec for ARM. So if you had looked at these scores probably a year or two ago, you would see them down here with the Pi because they were all in CPU. But yeah, it's much better, much better. Edge 2 edges out the kernel benchmark test. That's because it's a newer kernel, and that's the only reason. If they were running exactly the same, I would expect those to be the same. Machine learning tests, the Jetson has the edge because of, again, the GPU on that. But, you know, if both of these were able to use the NPU, that would be interesting because I don't think the Jetson would be in first place here. You know, these are both using Torch and TensorFlow to do these tests. So memory tests, the Mixtile has a little bit slower, and that, yeah, and that's just because of the architecture of the memory. These two both have higher speed memory in them than the Mixtile does. So, but it is respectable. It's right there. Multi-core tests, the Mixtile edges out the lead here, and geometric mean of server tests did well. I mean, it's close. The Jetson is just, this thing is so expensive too, and it should be way above this, and it's not. Yeah, what a surprise that Jetson would charge more. You could buy better, but you can't pay more. So the Mixtile did well here as well. This is pretty respectable, and it's very close to the single-threaded tests of the Edge. The geometric mean of the video encoding test, I would call that dead even. Yeah, that's down in the noise. And the same with this one, with the workstation benchmark tests. However, when you look at all of the results across all of the individual tests that make up this, the Mixtile was in first place 25 times, and there are 80 test runs here that were being done. And the Edge did not score as high as, so these are all kind of down here together. You have Pi, Jetson, and Edge 2, all kind of, as far as the ones that really exceed in the scoring of the individual tests, Mixtile took the lead. The rest of them are kind of tied for last, I guess you would say. And then you would see, yeah, it's just the opposite here, where Pi had 40 out of the 80, it finished last. Not surprising. And the Jetson, 31 out of the 80, it placed last. The Edge, 5 out of the 80, it placed last, and then Mixtile had 3. That's a pretty good score. I mean, really. Overall, I think this machine is excellent. And so, yeah, let's talk about some of the concluding remarks and finish up today. So we've had a chance to kind of look at how the board performs in different workloads. We first looked at Ubuntu and some of the feature set that it has. It looks like a standard desktop environment. It performs well with looking at videos and being able to do basic tasks with it. It seems very responsive to me. I don't notice any lag or anything in particular. Yeah, on the video, there was a few drop frames, but you know what? I get drop frames even on an Intel machine today, especially when it's in a heavier resolution that maybe is switching a little bit between scenes, and that's when you have to refresh the entire page. But it's not noticeable or objectionable. I think the last comment I have is that was kind of curious is that when you now and compute workloads with this device, it will use all 8 processors. But things I've noticed that are using AI type workloads, or maybe they're using models, only use the performance cores. And I don't quite know why that would be. Maybe they're reserving the efficiency cores for something that they have planned coming down the road. But, it seems kind of strange that why wouldn't you use all of the CPUs at your disposal? So it's not Mixtile's fault. That is Olama. That's their software design. I don't quite get that, why they wouldn't use them all. I did notice that on the Intel Ultra Core 7, they do use all 22 cores, even the ones that are supposed to be left for very low power computation. So they don't care. They just says 22 cores. Okay, we'll use all of them. I want to thank you for watching today. I hope you enjoyed this video. I think, in all honesty, I think I have found a place where I would be happy to use this as my next daily driver. So I'm going to be setting this up with my workloads here, and we're just going to put it in and start running on it for a month, and then we'll evaluate how well it did. Thanks for watching. Hope to see you all in the next one. Bye for now.